This is day 10 of Advent of Code 2024 Done and Go, and the challenge is called Hoof It. You all arrive at lava production facility on a floating island in the sky. As the others begin to search the massive industrial complex, you feel a small nose boop your leg, and look down to discover a reindeer wearing a hard hat. The reindeer is holding a book titled Lava Island Hiking Guide. However, when you open the book, you discover that most of it seems to have been scorched by lava. As you're about to ask how you can help, the reindeer brings you a blank topographic map of the surrounding area, the puzzle input, and looks up at you excitedly. Perhaps you can help fill in the missing hiking trails. The topographic map indicates the height at each position using a scale from 0 lowest to 9 highest. So for example, we have these numbers here. So this would be like a ramp going up, a ramp going up, this is going down, this is going down. Based on unscorched scraps of the book, you determine that a good hiking trail is as long as possible and has an even, gradual uphill slope. For all practical purposes, this means that a hiking trail is any path that starts at height 0, ends at height 9, and always increases by a height of exactly 1 at each step. Hiking trails never include diagonal steps, only up, down, left or right, from the perspective of the map. You look up from the map and notice that the reindeer has helpfully begun to construct a small pile of pencils, markers, rulers, compasses, stickers, and other equipment you might need to update the map with hiking trails. A trailhead is any position that starts one or more hiking trails. Here, these positions will always have height 0. Assembling more fragments of pages, you establish that a trailhead's score is the number of 9 height positions reachable from that trailhead via a hiking trail. In the above example, the single trailhead in the top left corner has a score of 1 because it can reach a single 9, the one on the bottom left. So the trailhead has a score of 2. So I assume that means the score is 2 because this 0 goes to this 9 and this 9 in the same amount of steps or distance. Okay, so it's just the trailhead score is the number of 9 height positions reachable from. Okay. Positions marked dot are impassable tiles to simplify these examples. They do not appear in your actual topographic map. So this trailhead has a score of 4 because every 9 is reachable via a hiking trail except the one immediately to the left of the trailhead. And then this topographic map contains 2 trailheads. The trailhead at the top has a score of 1, while the trailhead at the bottom has a score of 2. Okay, I'm not actually sure what that means. Trailhead at the top, then trailhead at the bottom. Okay, let's just continue reading. So here's a larger example. So with this one, there are multiple zeros within it. So this larger example has 9 trailheads. Considering the trailheads in reading order, they have scores of 5, 6, 5, 3, 1, 3, 5, 3, and 5. Adding these scores together, the sum of the scores of all trailheads is 36. Okay, interesting. So let's get started. So we've got, we're going to need to turn this into a grid. So we've got lines, need to do grid is equal to make. This will be array of interarrays, and the length is of lines. Then we need to do for I line in range lines grid I equal to make int array, which is the length of line. Then we need to do for j character in range line. It would then be grid I j is equal to int. This is, so it's going to be a rune. I've got the number. We need to do car, which is a rune, and minus rune 0. So I want to print out this map just to double check, and that seems to have been correct. So we have our grid created now. So we've got this. Now so we need our directions. This will be a list of 2 length interarrays. Then what we need to do, we'll do -1, 0 for up, we'll do 1, 0 for down, we will do 0, -1 for left, 0, 1 for right. So this will be a recursive challenge. We find a starting point, we then need to go explore each possible direction. We also need to keep track of where we've already been. So we'll go up, then maybe from here we go continue up, and or I should say, we start on the point, we pick a direction, so let's say up. Is this a valid, does it have a valid number? Which I think in this case, it needs to be 1, 2, 3, 4, 5, 6, 7, 8, or 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that's how this is meant to work. So 0, does this equal 1? Okay, let's go there. Does this equal 2? No. Okay, let's try here instead. Does this equal 2? No. Does this equal 2? No. That's where we've already just come from there, so we skip that. Does this equal 2? Yes. Now let's go to here. So it will be like that. So we need a recursive function, so need to first define what the function looks like, and then we can actually write it. So we'll call this explore, and this is a function, and this will take row, column, so we row int, column int. What number would we be passing to this? I guess height, I think. We will also need visited, which would be, what would this be? Oh, we can use a map, and this will contain int rev2 and bool. And I think that's all, but I just want to double check this. So it says sum of scores of all trailheads is 36. Okay, that works. I think that's all we need. So we've defined this, now we need to actually create the function. So explore is equal to this. Actually, we also need to keep track of where, what do we need for this? So we need to keep record of the places that have worked. Okay, we'll do a map with the coordinates of the 0, and it will contain a number of, it will contain the trailheads of the nines that is the coordinates that it has visited. Okay, we'll call this reachable 9, and this is basically the same thing as this. So we'll also put that into here. So we've finally got this sorted. Now what we need first is if row less than 0, or row is greater than the length of grid, or col less than 0, or col greater than the length of grid row. This will be return. Okay, so height will be the number we are looking for. So if grid row col does not equal height, return. So now we need to see if we've actually visited. So if visited, actually we'll first create current position is equal to int with row col. Now if visited current position, return. And if that's not the case, we then do this equals true. And now if current so if height is equal to 9, or in other words, we have followed the path and we're now at the location we're looking for, we then reachable 9 current position equals true. So it's possible that we start a position and we get to the same 9 through multiple paths. That will count, I think that counts as just 1 instead of it being 2. I haven't actually checked that. So this one is 4 because 1, 2, 3, 4 is reachable, and that one isn't. See this one is 2. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I get this one. So this one has this path, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this one has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it has 6, 7, 8, 9. So yes. Okay, so this one would be score 3. Okay, we don't really need to worry about what I was just thinking then. We'll find out when we test it. So we've reached 9 and we'll exit from there. So if we're at this point in time, we are on the right path, but we still need to continue. So for dir in range directions, next row will equal row plus dir 0, and next column will equal column dir 1. And we are now running this all over again. So then it'll be explore, next row, next column, then it'll be height plus 1, because we're now going to the next one. We're passing in the map for visited, and we're passing the map for reachable 9. So we have all this, and what we now need to do, we need to iterate through the grid, find where the zeros are, and then explore through those trying to find all the 9s. So we'll do for row equals 0, row is less than length of grid, and then row plus plus. Then we do the exact same thing, but now for column, col, but now we're doing grid of row, and we need to do if grid row col equals 0, then we start running on it. So what do we do here? We first need to create the visited map, and what do we define that as? Actually, we'll just copy this code here. So we start off with this one. This is equal to a map, and we'll start off, actually we need to make it. So we make it, then it'll be the same thing here. where we are creating it and then making it. We then just run explore with, this would be, okay, we'll set it as row col 0. So I was thinking, do we go to the next one and look for it, or we just start with 0? So if we define it as the height is 0, and we already know it is based on the for loops we just did, so row col 0, that will automatically just work and go to the next iteration of it, and then it'll explore from there going in each direction. So that works. Now we do pass unvisited and reachable 9. Now the output plus equals length of reachable 9. So these variables are created throughout these iterations. So on this current 0, these are recreated. We've got nothing at the moment. If we explore and we find any 9s which are reachable, then they'll be in here and we add them to the list. So now with that, we just print the output. So that should all be working in that code. So let's copy this, go to where the current input is, paste it in so we can test it on a known output, and we've got an error, undefined column. That should be col, so let's rerun that. And the output of this is 36. So if we get, okay, we've got an error. Run debug, where we row col. That's because I did the wrong condition here. It should be greater or equal to the length of the grid in the row. So we've done that, now let's rerun it. And we got 36. So we will undo the changes to our input. We will run it, and we should get the correct output. We got 659. So if we copy that, paste it in and submit, we will get the right answer. So that is part 1 done. Now on to part 2. The reindeer spends a few minutes reviewing your hiking trail map before realizing something, disappearing for a few minutes and finally returning with yet another slightly charred piece of paper. The paper describes a second way to measure a trailhead, calling its rating. A trailhead's rating is the number of distinct hiking trails which begin at that trailhead. So for example, there are 3 ways to get to there, and this one has 13. So this map contains a single trailhead with rating 227 because there are 121 distinct hiking trails that lead to the 9 on the right edge and 106 that lead to the 9 on the bottom edge. So here's the larger example from before. This would have a number of 81. Okay, so that sounds like essentially the exact same thing we had before, but for 9s visited, we need to change how that's recorded. So what would the best way to record that be? Change this to an int, I guess. Then when we do reachable 9, this would be plus plus. And then when we're here, this needs to be int. Output is not the length. Okay, so we need to change this as well. So for kv in range reachable 9, output plus equals v, I think. Let's switch to the test one and run it on that. 3636, okay, so that didn't work. Okay, so we need to find out, format up print, we'll print out the reachable 9, just so we can see what values it holds. Okay, so it has just 1 for all of them. I thought it, so it has different numbers here. Are we sure that it's the same input? Yes, it is. Actually, maybe instead of doing this, maybe what we do... Okay, yeah, so we don't need reachable 9. We are going to get rid of this completely. We are going to, within here, record... we will manually record the numbers for it. So we've got explore. This would be return 0. This would be return 0. Oh yeah, change this so this returns an int, and this returns an int. So these return 0. If visited current path returns 0. Actually, we don't need this, do we? Because this already covers it. Like, the only way if we've already visited a place, it's going to be a number that's lower. So we don't even need to keep record of this. So let's get rid of visited as well. Actually, I want to do that for this one as well, because visited is not needed at all. So I may as well just remove that. Although it's probably not the smartest idea to get rid of something like that while we're still currently working on it, but oh well. So here we do return 1. Don't need current position. So we're returning 1 here, and what we need is a variable called call it trails. So amount of unique trails that has reached 9. So we'll start off with 0, and when we're in here, it'll be trails. It'll be trails plus equals explore with an s, and then we return trails. So it's going to try every possible way through the paths, the directions, and from this point, it's going to try all the ways. It will then get the number from there. It's going to return that number to the one below it, which is then also trying all different possible ways. So it would build up the number like that. So we don't need these, we need this, and it'll be output plus equals explore. So we don't need that anymore. So let's run it, and hopefully I didn't screw up part 1 as well. 3681. There we go, we got it. So now let's switch it back to the actual input. We will run this. 1463. And that was the right answer. If you like this video, make sure to like and subscribe.